Welcome to the Scientific Sense podcast, where we explore emerging ideas from science, policy, economics, and technology. My name is Gill Eapen. We talk with world's leading academics and experts about their recent research or general areas of topical interest. Scientific Sense is an unstructured conversation with no agenda or preparation. We cover a wide variety of domains where new discoveries are made and new technologies are developed on a daily basis. We are most interested in how new ideas affect society and help educate the world how to pursue a rewarding and enjoyable life rooted in science, logic, and information. We seek knowledge without boundaries or constraints and provide unedited content of conversations with researchers and leaders who love what they do. A companion blog to this podcast can be found at scientificsense.com, and this podcast is available on over a dozen platforms and directly at scientificsense.net. If you have suggestions for topics, guests, and other ideas, please send them to info@scientificsense.com, and I can be reached at gill@eapen.info. My guest today is Professor Jack Burns, who's a professor in the Department of Astrophysical and Planetary Sciences at the University of Colorado, Boulder. He is also Vice President Emeritus for Academic Affairs and Research for the CU system. Welcome, Jack.
Well, thank you, Gil. It's good to be with you.
Yeah, thanks for doing this. So you and your team are deeply involved in the upcoming NASA missions to the moon, including the design to place a radio frequency observatory on the far side of the moon. And we haven't been really back there for almost 50 years now. I know that China has landed. I was actually looking at some photographs that just came through today from their lander. I know that Israel and India almost got there, but seem to have failed to land properly. And so what's our interest? What's our sudden interest in going back to the moon after 50 years?
Yeah, I don't know that I would characterize it as a sudden interest. I think on the part of the science community and really the exploration community, the interest has been there for a while. But what has changed in the last decade is the costs of doing missions and the accessibility of the moon in this new era in which we have now private companies like SpaceX and like the Blue Origin company, Jeff Bezos' company. They've put considerable private resources in developing new rockets with reusability to lower the launch costs. And also the technology, which was extreme in the 1960s to try to get to the moon and all had to be invented from scratch, now is relatively straightforward. Gil, as you mentioned, even small countries like Israel, private companies have contracts with NASA to fly payloads. So now it's realizable to envision going to the moon at a relatively modest cost, certainly in comparison to the 60s and 70s.
Yeah, so it's a very interesting phenomenon now. It's almost like a business model question, right? So there is SpaceX, there is Blue Horizon?
Blue Origin.
Blue Origin. And there is one other company, right? Was it Lockheed or something?
Well, Lockheed, ULA, the United Launch Alliance, which is Lockheed and Boeing company as well. They all have these new generation of launch vehicles that are capable of going to the moon.
Yeah, so NASA, in some sense, outsourcing some of the transportation, right? So have they made a selection, or are they going to essentially have multiple companies do it?
The plan is to have multiple companies, just like the commercial crew program to the space station. There's Boeing and SpaceX. And for the case of the moon, for the uncrewed landers, that is, landers that are just carrying payloads, NASA has identified about a dozen companies to be able to transport payloads to the moon. And at the same time, they're also undergoing a competition right now. They've selected 3 companies to design, as part of a public-private partnership, the next generation of human landers. So that's the same, mostly the same group. That is SpaceX, Blue Origin, and the third one is Dynetics, which is a company in Huntsville, Alabama.
Right, right. So is NASA's goal here is are they going to take contracts from other countries to send payload to the moon in the future?
Yeah. These companies, the way this is working now is NASA is buying services. So they're no longer buying rockets or landers, which they will then own and operate. Instead, the philosophy is to buy a ride, for example, a seat on a human lander, or buy space for a payload. So these companies then are responsible for indemnifying, making sure they have the proper insurance for losses. They take a good bit of the risk, and then proceed along those lines. Now, what that means is that the companies then, they own the intellectual property, they own the landers, they own the rockets, they own the other transportation devices. So that means they can sell seats, they can sell payloads to, for example, the European Space Agency, or the Russian Space Agency, or individual companies that might want to put a payload on the moon to do their own investigation in this kind of lower gravity environment. So it's much more entrepreneurial than what we had before, and it lowers the cost to the taxpayer for doing all of these things by, the Artemis program, which is the new human program to the moon. The recently released costs to get the first woman and the next man to the moon by 2024 is a factor of 10 less than the Apollo program.
Wow. Yeah, I mean, it's interesting. I remember, Jack, I was involved a little bit on the economic side of the Next Generation Space Vehicle Program, 2000, 2001, 2002 timeframe. And this was a program, as you know, was supposed to replace the shuttle. And we did not go forward with it. And I guess, so what was our arrangement with the Russian system to get our astronauts into the space station?
Yeah, the problem was that, you might recall, the shuttle accident that occurred in 2003, and then President George W. Bush declared that the shuttle really wasn't safe, and that needed to be replaced. And it took a while. We're still in the process of fully replacing it. The last shuttle launch was 2011, if I remember correctly. So in the meantime, in order to get to the space station, what we did is contract with the Russians to use their Soyuz spacecraft to go back and forth to the space station. So what we did is to buy seats. Those seats cost about 75 or 80 $1 million, so they weren't cheap, but it got us back and forth.
Right. Yeah. So before we get into the details of the various moon missions, Jack, I have a philosophical question. So, in a regime where we have technology advancing, we have artificial intelligence really taking off, machines are getting a lot smarter. What is sort of the basis for sending humans? Could we not accomplish everything that human could do with machines?
Yeah, that's a good question. I'm glad you answered that. You asked that question because, excuse me, I think what we're looking for now is a really different mode for doing work on surfaces like the moon or Mars. Excuse me. In that we, unlike Apollo, where you had, a single astronaut of geologists, such as astronaut Harrison Schmitt on Apollo 17, doing classic field geology with a shovel, to now advancing in the 21st century, what we're going to do is, I like to say, we're going to bring Silicon Valley with us to the moon. So we're going to bring advanced robotics that will
Yeah.
be teleoperated, that will use machine learning, artificial intelligence, and will team with the astronauts so that these rovers will do advanced scouting. They will identify interesting places, and then the role of the astronaut is to make critical decisions on what to investigate, what the samples look like. I still think it's true, and I've been told from my colleagues who are geologists, I'm an astronomer, but who are planetary scientists and geologists, that the difference, for example, between, let's say, the Curiosity rover on Mars and what it's been doing, and having a human on Mars, that the work that the Curiosity rover has done in the last 7 years could be done in 2 days by a human geologist. That's the difference. And to also bring back, better selected samples and so forth. So there's no replacing humans, and that's not going to happen anytime soon. But you do, your point being, you only want to use the humans when you absolutely have to, because their time is valuable and they're expensive, and also walking around even on the surface of the moon is dangerous because of the space radiation, micrometeorites, and other possible dangers. But going into this new environment, I think what we're going to be able to do is reduce risk and improve efficiency.
Mm. I don't remember the numbers, Jack, but a human mission is about 10x the cost of a non-human mission. Obviously, the efficiency and like you say, what we get out of it is different. But just on the cost side, it's about a factor of magnitude different, right?
That's hard to say because robots still are very limited in what they can do. There are just so many things that only humans can do. So it's a little bit of apples and oranges, but yeah, you're probably right that on the ballpark about a factor of 10, maybe even more. But there's also much more than a factor of 10 improvement in efficiency.
Yeah,
So, those costs will balance out.
yeah, and obviously the advantage of a human is that when the unexpected happens, machine learning is fine as long as you have a lot of data to teach a machine with. But when the unexpected happens, the machines are not
Well,
that useful.
exactly. The rover gets stuck. It suffers a mechanical problem that if you have a human there, at least in the vicinity, can help fix it and move forward. I think about, for example, servicing of the Hubble Space Telescope. And that was done 5 times by human astronauts. And the astronauts, such as John Grunsfeld, who did 2 of the servicing missions, was very clear that the telescope could not have been repaired and upgraded by anything other than humans, because the complexity of the task, the ability to be able to get in and to make repairs, make on-the-spot decisions, just there was no replacing that.
Right, right. So hopefully humans have a few more years of job
I think we've got
security.
many years, to tell you the truth. I think it's going to be, in reading some of the literature, I think it's going to be quite a long time, if ever, that we have truly intelligent, self-aware machines that can operate with the same decision-making capability. They're very good at repetitive calculations, do an outstanding job there, but making creative, innovative, entrepreneurial decisions, we're nowhere close to that yet.
Right, right. And so I know there are multiple missions being planned. Some of it is with an international collaboration. So it's the first one that is supposed to take off is named Artemis.
Yeah, Artemis is the new name for the human missions to the moon. Artemis in Greek mythology was the sister of Apollo, the twin sister of Apollo. She's the goddess of the moon. So that's very appropriate since NASA's already declared that for that first landing, which NASA has been planning for 2024, would have that first woman and the next man on the surface, the first expedition by humans to the moon in the 21st century.
So Artemis is like Apollo. Then it's the name of the
Name
program,
of the
and
program,
under
yeah,
Artemis.
exactly right.
So under Artemis, you have multiple things going on. And so do we have sort of a space station-like thing that is going to orbit the moon?
Yeah, in fact, that's under design and will be under construction in the next few years. It's called the Gateway, the Lunar Gateway, and it's not like the space station in the sense of being gigantic and being really limited to that single orbit. The Gateway is really more of a spacecraft. It's going to have a propulsion system using a new generation of solar electric. Think of that as ion propulsion system that will be piloted for potential for future use in going to Mars. And it'll have just a couple of modules that will be there. It will be a place where astronauts coming from the Earth on the Orion spacecraft, which is the it plus the Space Launch System, is the heavy lift vehicle that will take astronauts to the moon. They will dock at the Gateway, and then they will get into a reusable lander, go to the surface, come back in that lander, and then the next crew that comes in will do the same thing. So you don't throw everything away like we did during Apollo in the 1960s. Again, the reusability idea is key to keeping the costs down.
So it is modular. So can we attach as our ideas change in the future? Can we attach more modules to it?
We can. In fact, the Japanese space agency JAXA recently committed to fly a module, and NASA has invited others, such as the Russian space agency, to think about attaching a module as well. So it definitely is modular that way, and you can add habitats, you can add laboratories, and this can grow over time. But it's also the idea is that it's going to be long duration space flight, and it's away from the Earth's magnetic field, so you've got the full radiation environment of what you would have going to Mars. So I think NASA also looks at this as a prototype of the vehicle that would be sent to Mars.
Okay, so there were some conversations, Jack. I can't quite remember that to go to Mars, you would rather start off from the moon. Is that still the thinking, or that has changed?
I don't think that's been decided, but there's some potential real advantages of the moon. First of all, launching from the moon versus the Earth, it requires much less thrust, what we call delta V. That's a change in velocity
Yeah.
to get off of there because there's only 1/6 the gravity on the moon. And secondly, if we're successful in mining water from the moon, and we know now there's a considerable amount of water um, at the poles of the moon. That's hydrogen and oxygen. We can convert that potentially into rocket fuel. You wouldn't have to bring that from Earth. So the costs associated with launching um, could be substantially reduced in doing this from the moon versus from the Earth. So people are actively working that right now and seeing if that might be the way to go. I kind of think that might end up being how missions to Mars are undertaken.
Mm. So under Artemis, are there plans to actually create a habitat, a big enough habitat for people to stay for extended period of time?
Yeah, so NASA has designs, and once again, I should mention this is all international.
Yeah.
ESA is involved. The European Space Agency is involved in providing a module for the service module for the Orion. It also will be working on the Gateway. The Canadian Space Agency is providing the robotic arm, and the same will be true on the surface. The idea is that the first few missions will just get started. That first mission in 2024 is planned to go to the South Pole of the moon, where we've never been to before, and look at the water ice situation there. But over time, by the end of the decade, the expectation is that we'll have multiple habitats and we'll have people staying there for long periods of time, kind of like the Antarctic station
Mm.
that's run by the National Science Foundation, the McMurdo station, as it's called, in which you have a number of scientists come in and visit for anywhere from a few weeks to staying for a year.
Mm. So, so I remember when the next generation space vehicle program was in progress, space tourism was a big objective. I would imagine SpaceX and Blue Origin and others have this in their business plan. Um, so what's the transit time to that to the gateway?
Yeah, so it'll be somewhere between 3 and 5 days to get from the Earth. And you're right about the tourism. SpaceX already has identified a Japanese businessman, if I remember correctly, who has bought a ride not to the surface of the moon, but to orbit the moon on a SpaceX vehicle sometime in a few years. But it'll be 3 to 5 days to get to the gateway, and then another day to get down to the surface. So I fully expect by the end of the decade, especially given the accessibility to the moon by the private sector and by these companies, that they will be selling seats to wealthy individuals to spend a summer holiday on the moon.
Yeah, I mean, so if the gateway is expandable, perhaps the taxpayers can make some money through NASA.
Well, it might be, yeah. I mean, but once again, this is the transportation for the most part is probably not going to be through NASA, but by these individual companies who own their own rockets, their spacecraft, and they will sell seats to wealthy tourists.
Yeah, yeah. And so you mentioned the European Space Agency, you mentioned the Canadian Space Agency. So is this like the space station a larger collaboration, or those are the three major ones?
Yeah, it is, and you're right. There are oh gosh, there's probably a dozen or so countries rather, that are involved in the International Space Station, and NASA envisions this very much the same thing. And first order, all of the countries that are involved in the International Space Station have been invited to become involved with the Gateway. And so, as I mentioned, several have accepted with enthusiasms. Others are still kicking that around.
Mm-hmm. We'll take a quick break, Jack. When we come back, I want to talk about the radio frequency observatory on the far side of the moon that you're designing.
You bet. Sounds good.
This is a Scientific Sense podcast providing unscripted conversations with leading academics and researchers on a variety of topics. If you'd like to sponsor this podcast, please reach out to info@scientificsense.com. We are back. Jack, we are talking about the upcoming missions to the moon. Some of the manned missions, some of the technology that we are sending up there. There is a gateway which is like the space station, but it has its own propulsion, its own solar-based energy source, and it's modular. Things could be attached to it. There are various objectives, including creating a launch pad, so to speak, to go to Mars, perhaps habitats that are large enough, mining for water, mining for hydrogen and other things. And so this program, the program is called Artemis. So it's going to be an Apollo-like program. And underneath Artemis, there are various things being planned, right? So what are the primary objectives of those various projects, I should say, under Artemis?
Yeah, well, Gil, let me start off by just looking at the difference with the Apollo program, because the Apollo program ended fairly abruptly once the political goals were reached, and it was never really a sustainable program. So what NASA and I think all of the governmental space agencies are looking for is for Artemis to be the beginning of a sustained presence on the moon and in space, and using the moon as a stepping stone for human and robotic exploration of the solar system, including getting to Mars. So the philosophy of Artemis is really quite different. So you're there to stay. So you need to figure out how to live off the land. So that does mean, as you were saying, mining some water, being able to grow crops, being able to manufacture equipments, the habitats themselves from the regolith or the soil material. So using the kind of advanced manufacturing capability, 3D printing, electrolysis. So that's a really different approach, and it means that what will be worked on is not just get there, put a flag in the ground, grab a handful of soil, and return. Instead, it means how do you figure out how to be there for the long haul? So that means then learning how to excavate, how to build, how to really maintain life in a certain sense of independence. Part of the reason you want to do all of that is because that's exactly what's going to be necessary for Mars, because Mars is so far away that right away in the first human mission, they're going to have to do all of those things. So let's figure it out on the moon first, where we're still only 3 to 5 days away.
Do we know, I guess we should know by now, is the moon reasonably mineral rich, just like the Earth?
Yeah, it is. It's in a different location,
Yeah.
but the soil, the regolith, if you will, they don't have the same kind of iron and nickel deposits, but all of these materials, magnesium, aluminum, are in the soil, and so you have to do some processing to extract that. But the techniques are well in hand to be able to do that. So everything from paving roads to building habitats are possible and must be made doable, because that's what we're going to have to do on Mars as well.
Yeah, so that is clearly philosophically a very, very different thing. So we will excavate, we will refine materials, we will create components, assemble, manufacture, actually create a craft that could then take off to Mars or wherever.
Well, maybe components of that. And once
Yeah.
again, the idea of doing that in the 1960s was real science fiction. That just was not possible, and that's part of the reason that a lunar program wasn't maintained. Today, this is fact. This is, as I said earlier, all of the technologies developed by Silicon Valley and beyond are, we're going to take all of that to the moon with us and utilize it.
Yeah, so that goes into the cost, like you mentioned, Jack. So I think if I understood that correctly, Artemis program in today's dollars is about 1/10 of the Apollo program.
Yeah, so the Apollo program was about $250 billion. And NASA Administrator Bridenstine has requested $25 billion through 2024. So that's not all in one year, but distributed out to do that first mission to the moon. And the majority of the cost is we've already invested in the new rockets and the Orion spacecraft. So it is in, for example, building the new human rated landers and the gateway and the infrastructure.
And how about the other countries? I know that China, India, Israel, Russia, all are interested. How do their plans fit with ours?
I think overall, they fit very well. Again, the collaborations we've had internationally with the International Space Station bode well for this in the future, because we've already figured out how to do this, how to share resources, how to make sure that interfaces are common, and that electronics, work in the different environments. So that's well underway. The one country, for political reasons, that we don't work with in the U.S. is China at this point. But who knows? That might change in the next decade as well.
Right, right. And I understand, Jack, that most of the water is on the far side, the side that we cannot see
Well, most of it's actually at the poles.
at the
Yeah,
poles.
and so some of it is accessible, like this Viper mission that NASA is going to send to the South Pole in advance of the Artemis human landing. It is close enough to the near side that there'll be direct radio communication from the South Pole to the Earth.
And so is Artemis focus is going to be on the far side?
No, not necessarily, because there's interesting places to go to on the near side and the poles. Certainly, the far side that's unexplored territory, and the far side has a very interesting geological feature. It has something called the South Pole Aiken Basin, which is the largest, deepest, oldest impact crater that we know of in the inner solar system. And scientists are just really eager to get in there and to sample that location, because it's going to tell us about the early history of the formation of the moon, but also the formation of the Earth.
Are there any other benefits, such as lower levels of radiation or anything like that on the far side?
Not lower radiation, but the other benefit is that it's quiet. It's radio quiet
Hmm.
on the far side of the moon. So from the Earth, we are limited in being able to do observations below, roughly 100 megahertz or 80 megahertz. So in other words, below the FM band. And that's due to the Earth's ionosphere, which absorbs some of the radio radiation and refracts it. But it's also due to radio frequency interference. And so there's a whole portion of the universe at radio frequencies that we've been unable to probe from the Earth. But going to the far side, where it's radio quiet, there is no ionosphere around the moon. For the first time, we're going to open up an entirely new epoch to investigate the very early universe.
Yeah, so that's very interesting. So you have a project, a radio frequency observatory that is being planned there. So from a cosmology perspective, Jack, so this is an epoch. I understand that the CMB sort of at 380,000 years from Big Bang. So this is post that time zone, right? That is what
Right.
we are trying to explore.
Yeah, that's correct, Gil. It's that's the beginning of what's called the dark ages of the early universe. So the universe at that point is transparent, but there are no stars, no galaxies yet. They're still collapsing and in the formation stage. So the dark ages is filled with neutral hydrogen, and that hydrogen radiates at low radio frequencies, so below 100 megahertz, and it will allow us to probe the physics of that early universe. So we'll be able to test more thoroughly models of cosmology, inflation, and also the early stages of star formation, to be able to look at time periods that we can't get to with the Hubble Space Telescope or even the upcoming James Webb Space Telescope.
So this is the era, as the photons escaped at 380,000 years, and before stars formed, we can actually see using something like Hubble telescope or something along those lines. It's the time where it's just dark and it's just hydrogen mostly.
Yeah, that's right. So there's a big gap in our understanding of the universe from this roughly 400,000 years after the Big Bang that you mentioned, the cosmic microwave background, the start of the dark ages, until where the Hubble Space Telescope begins to probe. And that's about, I would say a half to 3/4 of a billion years. So there's a huge gap. All of this interesting physics and astrophysics is happening. Objects are collapsing, forming the first stars. Those stars are coming together to produce the first galaxies. And the only way we know to be able to sample it is using that neutral hydrogen emission and looking at what the impact on the hydrogen is from the formation of those stars and galaxies. So it's a unique way of probing the early universe, and the moon, the far side of the moon, is the only place we can do this.
And so the measurements will be just spectrum, right?
Well, they would initially, using just a single dipole telescopes. We can look at sort of the global signal, looking at the spectrum. But then with time, what we want to do is to build an array of radio telescopes on the lunar far side that will give us some spatial resolution. So we'll be able to map out the density fluctuations of the neutral hydrogen in the early universe and tell us much more about those first stars and galaxies and also the early cosmology. So what we want to do is we start off with just single antennas on the surface of the far side and work towards building these arrays. Eventually, having maybe 100,000 dipole antennas on the far side.
Oh, yeah. And so Jack, do we have some expectations of density and other things like from standard models? So could we either confirm or potentially reject some of those expectations?
We can, yeah. In particular, what we want to do is we really want to test the standard model of cosmology. And in particular, is there any missing physics? And there's some indication from recent observations that dark matter may be playing an unexpected role in cooling the neutral hydrogen. And that means that the characteristics of the dark matter, this is a kind of non-gravitational interaction. The characteristics of that dark matter is quite different than what we thought. So these experiments actually could be a way of probing the dark matter in the universe, which, as you know, makes up some 90+% of the mass in the universe.
Right. And right now, we don't really know what it is.
We don't. Right? No, absolutely. That's an embarrassment, I think, to both the physics and the astrophysics community. It's the dominant form of mass in the universe, and we've not been able to detect it from the ground. Only indirect detections from astrophysics observations.
And so, is it possible for us to see some, sort of timelines of how that changed, and that might give us some ideas how dark matter might have played a role in star formation?
It could, and how it might have also affected the evolution of the universe in maybe ways that we don't anticipate. Some of these models give dark matter a small electronic charge, a fraction of an electron that allows then interactions with matter. That again would be quite surprising. So what we inevitably do, Gill, is anytime we turn on a new telescope, particularly at a new wavelength, the history has been we learn something new and surprising. And I think we very much expect that to happen when we turn on our first radio telescope from the far side in the next few years.
And this sounds like a really big thing, Jack. So you said thousands of these dipole.
That's eventually. I mean, we start off small, as I mentioned. We start off with a single antenna, and next year our first radio telescope is going to fly to the moon with one of these small companies that I mentioned to you that NASA has contracted to bring payloads. This is a company called Intuitive Machines out of Houston. They're going to bring our radio telescope. Initially, it's going to be on the near side, and then a few years later, that's going to be followed by a mission on the far side. So we get this going, and then hopefully by the end of the decade, we're able to put down an initial array that will have 100 or so of these dipole antennas to get us started. And then the nice thing about these arrays of radio telescopes is we can just build them over time, maybe even manufacture the antennas from the lunar stockpile of material.
Yeah, I was about to say what you need is some sort of a self-replicating process.
Exactly, because when you're doing thousands of these things, you just generate them and then put them on a rover, and the rover takes them out and deposits. You don't necessarily need humans to do that.
And so, what's the ultimate goal? What would be sort of the area that you might cover for this whole entire thing?
So it really is hitting a couple of areas of scientific interest. So I would both refer to them as sort of our cosmic origins. So, cosmologically, it's trying to understand the very first stars and galaxies that were created in the universe that eventually led to our Milky Way and to our sun. So, probing how we get there. The other thing that we can do with this array, the other goal is we're going to be looking at nearby exoplanets. And there we're probing at these radio frequencies a different aspect of habitability. That is, do these exoplanets have a magnetic field? And we know in the case of the Earth, the magnetic field is really important for life because it shields us from all of the harmful space radiation coming from the sun, as well as from supernova remnants and material supernovae that happen outside the Milky Way. So with these radio frequencies, we can actually, and an initial array will have the sensitivity necessary to determine, in looking at these nearby exoplanets, which are being discovered daily, whether or not they have magnetic fields, and therefore are they good targets for habitability.
Yeah, that's really interesting. So the 4,500 or so exoplanets that have been discovered, one attribute we can assign to them is whether they have a magnetic
Right.
field. So this could fill in the
fill in the gap, and doing this at radio frequencies is the only way that we can do it. And the radio frequencies are very low; they're below the ionospheric cutoff. So once again, it's one of these things that you absolutely must do this from the far side of the moon.
Is magnetic field a necessary condition for habitability?
Well, that's a really good question. I think this is actively debated in the community. We know it's absolutely essential for life on the Earth because if you look in contrast to Mars, Mars had a magnetic field early on for probably the first few billion years, but then its core cooled, the magnetic field shut down. And as a result, the atmosphere of Mars, which once allowed liquid water on the surface, thinned out over time. And so today, Mars has been transformed into a desert planet. It's really hard to imagine any form of life, certainly on the surface. There may be some microbial life in the subsurface. So here, that's a good example, a lesson, if you will, of how a planet changed dramatically from the time that it initially had a magnetic field to today, in which it has no global magnetic field.
So is it radiation that it's trying to?
It is, yeah. The solar wind, which blows from the sun, it contains mass and velocity, and so it's very effective at stripping atmospheres. It didn't strip the Earth's atmosphere because once again the magnetic field deflects this solar wind, which is made up of charged particles, and so it just deflects around the magnetic field, leaves our atmosphere alone. The solar wind, in the case of Mars, that space radiation just goes right to the surface of Mars these days. And that's not true. If that was true in the Earth, we wouldn't be here.
Yeah, so just Jack, I don't know much about this, but I just wanted to get your perspective. So there are some hypotheses around planets around white dwarfs, red dwarfs. They are not that hot, so they can be closer. But then, the radiation effects could be too high. So if we find a planet that is close but has very high magnetic field, it might still then considered to be potentially habitable.
And that's the kind of trade-offs that you want to look at. So many of the nearby stars are these red dwarf stars. They're also called M dwarf stars. They're cooler. than the sun. They're smaller, but they also seem to flare a good bit. And the habitable zone where water would exist is closer to those stars as well. So I think folks are worried that that environment might not allow life to exist on those planets unless you did have a fairly strong magnetic field. So yeah, it's the kind of thing that you'd want to look at and look for and investigate. And we'll have the capability of doing that in just a few years with the radio array on the moon.
Yeah. This is an exciting thing, Jack. A lot of different objectives. It's going to be a process, a long-term process. From an economic investment perspective, substantially more efficient than the missions that we have had in the past. So given all of that, in conclusion, Jack, if you look forward, say 5 years, 10 years, what are your expectations? Where will we be in 5 years, and where will we be in 10 years?
Yeah, I think we'll be on our way back to the moon with humans in 5 years. I'm not sure we're going to get there quite that time, but I'm confident that certainly by a few years after that, we'll have the return of human astronauts to the moon. I also expect a good bit of scientific infrastructure to grow up on the moon, not only our radio array that we were talking about and our radio telescopes, but other scientific infrastructure is going to investigate the geology of the moon, understand in different locations, mining water ice, turning it into fuel, mining other materials on the moon. So by the end of the decade, in 10 years, I expect to see a thriving scientific and really in industrial entrepreneurial community that has arisen.
Excellent. Yeah. Good luck with this initiative. And thanks so much.
You're welcome, Gil. It was a pleasure.
Thank you. Bye. This is a Scientific Sense podcast providing unscripted conversations with leading academics and researchers on a variety of topics. If you'd like to sponsor this podcast, please reach out to info@scientificsense.com.